do all the different patches, 20 different patches, you need to apply, actually result in a working database, or has someone gone in and manually edited a database and fiddled with things? People did it all the time.
Yeah. All right, welcome everyone to the Bioinformatics Lab podcast. I'm Kevin Libwit with Andrew Page, and today we're talking about dev environments, something that is, for a lot of folks, the obvious conversation of what a dev environment is, how that relates to production or staging. But to a lot of people maybe coming into the field, especially from academia, and I would very much include myself into this when I kind of originally got in the field, I had no idea what a dev environment was. I had a environment, and that's where I did all of my work. I wrote the scripts, I edited the scripts live because I was the only one who needed to use these systems, and I didn't even think about the ways in which I was mitigating risks by separating these environments. But of course, as I've come to develop my skill sets and had needed to maintain resources that were meant for production use, I started realizing, wait a minute, there's a huge utility in making sure I have a separate environment. So, Andrew, obviously, again, you come from the software engineer world, so I'm sure these were sort of ideas ingrained into you much earlier than they were in my world. So, what are your thoughts on dev environments, prod environments, and all the world of bioinformatics and their adoption of these practices?
You'd imagine you'd be taught this in university, but no, you're not, because obviously people lecturing you, in computer science software engineering are not people who have necessarily been in industry and done heavy duty software engineering. So actually, I learned a lot of this stuff when I was just in my first few years out of a postdoc in working in the Sanger Institute from other professional software engineers, and they're like, this is how we do it, and it's more like an apprenticeship. I learned so much from them, just about how you go about building professional software, and like the ultimate goal is, when you have something that our lab relies on, you don't want to change it all the time. What they want is consistency. They want it working. They don't want it to be working one day and then broken the next, and then working again, or having features changed, or having subtle outputs changed. No one likes that. They want stability, and you can see that with some labs will use software for a decade without changing the version, simply because they know it works. It's been validated in a protocol somewhere, and they absolutely do not want to touch it. That is what happens. You see it in factories as well, with machines. That runs a production line. You don't want to change it. That's your bread and butter. It makes you money. Having a break is a really, really bad thing. So, unfortunately, with bioinformatics, a lot of it is academic developed, and people are doing rapid prototyping. They want to test things out. They want to change things. They want to see, okay, what happens when I do X, Y, and Z, and does it, improve the results or not? They're writing a paper probably at the same time, or they're writing a thesis, and that's a very different way of doing things, because you want to move fast in that situation, versus the slow kind of production, heavy duty, don't break anything.
Yeah,
So yeah,
I was going to say, and it's funny because now we're on the applied world of microbial bioinformatics, where it's a lot of us do come from academia, so we want to move so quickly, but we realize, hey, we do need a little bit more static state production code. And in the world of it's so dynamic, so we often come into the places where we do have this production code, but okay, we do have a feature request. I'm not going to add it right now, but let me roadmap this out and figure out how do I put my development environment up and set so I don't touch the production code. So this is where the conversation of dev environments comes to play, where you're really trying to have a separate compute resources, a whole entire, if possible, compute environment in its entirety, that mimics a lot of the production environment as closely as possible, so that you can get a copy of that source code and you can tinker, experiment, and go about your development work without in any way impacting that main production code base. And of course, the intent here is for risk mitigation. You don't want things that are untested, not validated, that could potentially introduce bugs touching your production code, because for obvious reasons. But again, it's worth saying because when I first came into the space, I wasn't thinking about this. I wasn't thinking about a production line versus a dev line. I was only thinking of, I need the thing to work right now. But I got myself caught in so many situations where, I remember even at the Virginia lab when I was kind of early in my career, where again, I had one environment. I would write a pipeline, and I remember it was for serotyping salmonella, and then I got the request to, hey, by the way, can you ensure that the sample name is printed in this exact way? They wanted it tagged, I think, with like a date for the analysis every time, as well. I was like, oh yeah, absolutely, I can make that change right now. And then, me being sort of naive, early young developer, I made a change. I think at that point I introduced some kind of white space that threw everything off, but I didn't catch it. So I said, hey, it's ready. You guys are set. And then it was like, the Friday night, done, wipe my hands, everything. And then they had some analysis to do early the next week. And I come in like, hey, Kev, it's not working. What the heck happened to the source code? Like the pipeline you had is not working. And then I just had this cold sweat of like, oh shoot, it's completely broken at this point. I introduced that bug. Now my downstream users don't have a working copy of this source code, and I had to frantically get into that state, find the bug, revert it back. I had to make that decision too. Do I just revert it back, or do I try to double down and try to push this forward? I just kind of retreated. I reverted back, and then I told him, hey, okay, here's the copy of the production code as it was prior to me making the change. Let me make a copy of this before I actually hand you anything. That was the first introduction to a primitive dev environment. A copy of the code, even on the same machine, where I could say, let me tinker with this first before handing it off to you guys. And that was my introduction to the utility of dev environments.
Yeah, so there's different ways to do it as well. A dev environment, that you have, you might have a scripted build from scratch, or maybe Docker container, building everything, which is great. But your production environment is actually going to be incrementally updated. You never stop production; it always goes on, and you'll always have, say, your database, for example, or your data, and then you kind of update the code, and you might make minor changes, but it's always you've got something and it progresses versus a blank slate for development. And that's kind of where staging comes in a way. Often you'll take a snapshot of what's in production, put into staging. You can test out things. You can, get other people to have a look. You can see how multiple different developers' changes have interacted, and so you have that kind of basically test site, staging site, to make sure that what you want to do is actually going to work at the end of the day, which is without breaking stuff. And it's really handy to have that, and usually it very closely mirror production. And then it's a very simple switch over. You can obviously then what you're going. Say migrations for a database are going to work. Or changes to some data or pipelines, they're going to work. So you can be far more confident.
That's a big part of it too, especially at that staging step, because there's so much software dependence of like resources outside of even just like the one module you might be developing, where you want to make sure, like, if you're calling a database, from the Google Cloud Registry or even a different container or something, everything that all the changes you made, maybe even in your dev environment, still work within the whole comprehensive software suite that you're working with. So that kind of final area where you're prior to production, you're still giving it final tests. So it's like really this has been a theme over a number of our episodes. The conversation of testing, ensuring your code is stable along the way, all the way to the granular unit testing, to this conversation of functional tests all the way through. We talked in the past, I think, about automated tests that are invoked by things like GitHub Actions on different repositories, all of which are aimed to the intent of once it hits production line, we have confidence in this. Of course, there's always going to be errors that get introduced, but we want to limit that as much as possible prior to handing this off for the end user, because the end user is really dependent on high quality results that they can routinely generate and produce for the responsibilities they're tasked with there.
Absolutely. And so what the first thing I will do, when I get a piece of software from someone or inherit it from someone, is to work out those dependencies. And the way I do personally is I build a fresh Docker container. We're starting from scratch with nothing in it, load in the software, then try and figure out, is how they've documented the installation process actually what matches. Because there'll always be, these hidden libraries and stuff that someone's installed on their laptop and they can't remember how they installed it, or even why they installed it, or how they configured it, or which version they put in. And so it's that step of actually, systematically going through and going, actually, yeah, you need this, 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 and this. So then it can be automatically built. And then you have, even though it's a Docker container, you have like a record as well of exactly from scratch, how is your software set up, configured, and built. And often, like, you can even apply different migrations and patches, so from the very starting scheme of a database, do all the different patches, 20 different patches, you need to apply, actually result in a working database, or has someone gone in and manually edited a database and fiddled with things, people did it all the time.
Yeah.
And you can see how it goes, and then you can be more confident in what happens in production. But I guess we were talking a lot about software engineering concepts here, and this is a Bioinformatics podcast, and how does it actually relate? Well, I think it's more that this is how you go from the quick, rapid prototyping bioinformatics, in an academic setting, to the long term. We need something stable that works no matter what. It's to the bulletproof production bioinformatics, and that's a harder and bigger lift compared to the other. And that's what we need to do. We can't all just be playing with technology and fiddling with things as we see fit. Sometimes you just got to step back and go, actually, no, it's good enough. It does the job. We don't need to do this again.
Oh, I'm glad you brought that home to the applications in our field. And what you're seeing is a maturation of the field where the innovations are coming from academia, but now it needs to be put in the hands of a really wide user base because of how transformative the technology is. But in order to confidently hand that to these end users, it needs to be, I love that phrase, bulletproof production ready code there. So what you're seeing in the field is a lot of just maturity in the status quo development practices, especially in the ways in which we develop across institutions. We all need a common language. We all need to be able to understand the ways in which we're engineering our code, so that if I'm going to adapt a certain system, I have certain expectations. Again, we getting back to the conversation of unit testing, or automated testing in general, like that is now an expectation. The ways in which people are using, version control systems, like that is all a part of this, where it's a maturation of the field, which requires maturation of our practices. And a lot of those practices are hardened in fields outside of bioinformatics. So like I think in us starting to adopt some of those different softwares, like we've mentioned containerization and Docker, the conversations of cloud computing and infrastructures. These are wildly mature softwares. Their best practices exist in fields outside of public health bioinformatics, because they've always been aiming towards a wide, bulletproof, production ready user base there, or software for that user base. So it's forcing us to adopt a lot of these more software engineering practices for the practical end use of getting these technologies more readily accessible to a non-technical audience.
Absolutely. And I guess I hope in the future that people won't go and, I don't know, write another short read mapper or short read assembler or things like that. Those are well solved problems. But I guess, as the academic in me is like always, oh well, I can do it better. I can make that 0.0001% improvement, forgetting that those have been battle hardened over a decade, and they've earned out all the edge cases and bugs. And yeah, it's certainly an interesting time seeing the professionalization of it. And ultimately people are making decisions, based on the bioinformatics data. It's not like you're in a university doing a retrospective study with samples collected a year or 2 or 3 years ago and publishing a paper that eventually gets out and people might read or might not. These are, when you're doing, say, public health surveillance, the information is being used and it is informing policy, and it is informing high level decisions in how to manage different diseases within an environment, or it might be for outbreak investigations, and where you need to do product recalls and things like that. And so it is actually real life impacts are occurring, and you need to have confidence in those, and you need to have confidence in them over time. Say if I don't know, if you're doing lineage calls on, or sequence type calls on particular pathogens, you want to make sure that those aren't going to change. And so you can compare what happens today, you compare it to what happened last week or last year. And that's where we need this kind of higher level of professionalism in bioinformatics and public health.
We have that conversation internally a lot at Theogen, where we all come into the sciences because of that innate curiosity of wanting that sort of not point not percent optimization, because that's, we thrive on that. We have that internal curiosity. In a lot of ways, a lot of us self-identify with that curiosity and drive for understanding things. Getting into the world of application, it's like you want to encourage and foster that curiosity and that drive for continuous improvement. You just want to sort of narrow the scope a little bit. It's not curiosity for curiosity's sake. It's curiosity for how do we best pragmatically solve the problems that our user base are facing there. So it is a small change in trajectory, where when you're in the applied space, it is the endpoint is serving your user base there, and harnessing that curiosity of energy, or curious energy that we all have for that pragmatic end goal, which is of course different than in the academic space. You want the curiosity for curiosity's sake. You don't know what the pragmatic end goal is. That's the beauty of being in the academic space. And then the beauty of being on the more applied space is we know there's a pragmatic end goal. We've defined that end goal. How do we make sure that we're actually hitting that target with the full force of all of our, our curiosity and passion?
Absolutely. I think, yeah, we'll leave it there.
All right, yeah, great conversation. That I'm curious to see what others have to say on this. So we'll see everyone in the next one.